500 million years ago, during the lower Middle Cambrian period, portions of western Queensland were covered by an extensive sea. In the restricted shallow water environment along the margins of this sea, great numbers of primitive marine creatures thrived in waters unusually rich in phosphate. Phosphate sediments and the remains of these tiny animals accumulated as thick beds on the sea floor. Until recent times, these unique sediments remained buried, finally to be exposed as the landscape altered through the agencies of sun, wind, and rain. Just as phosphate was important to the survival of these primitive forms of marine life, man is becoming increasingly dependent on the rock in which they are preserved. The discovery of phosphate in 1966 by B.H. South is a classic in the history of mineral search. Exploration was directed to northwest Queensland, south of Mount Isa, the regional centre. The successful discovery was preceded by 2 years' study of the nature of overseas phosphate deposits and exploration methods. Research studies of Australian sedimentary basins were carried out to determine favourable phosphatic provinces. This, the first systematic exploration for phosphate in Australia, was rewarded when a 1,300 million tonne deposit was found near the settlement of Duchess. Subsequently, a further 9 deposits were discovered, of which Lady Annie and the adjoining Lady Jane are the largest. The total reserve of the 10 deposits, exceeding 2,000 million tonnes, represent a significant increase in world phosphate resources and will provide for the long-term needs of Australia and her neighbours, reducing dependence on more distant sources of supply. Each of the 10 deposits was located by detailed surface prospecting and sampling. Diamond drilling was used initially to gain lithological and stratigraphic data and was followed by some 100,000 metres of percussion drilling. Shafts were sunk and excavations bulldozed to provide materials for metallurgical testing, to create exposures for geological study, and to provide bulk samples for beneficiation trials. Seismic surveying indicated that overburden and phosphate could be removed without blasting. With the growing awareness of environmental considerations, B.H. South undertook studies in the early stages of investigation to establish methods to minimize disturbance to the ecology of the region. The nearest coastline is the Gulf of Carpentaria, and the large Duchess deposit is the furthest south. However, initial production planning centered on the Lady Annie, Lady Jane deposits closer to the Gulf. The completion of 5 test excavations confirmed that both the phosphate and overburden could be economically removed by wheeled scrapers after ripping. It required 5 years of research and testing before high-grade concentrates were produced. The decision was then made to install the 100-ton-per-day pilot plant adjacent to the Lady Annie deposit. Earlier tests indicated that the rock was amenable to autogenous grinding, and the 3.6-meter diameter mill forms an integral part of the pilot plant. This unique plant is producing high-grade phosphate concentrates for full-scale fertilizer plant tests and is providing metallurgical data for the detailed design of the future concentrator. The Australian Fertiliser Company's technical laboratory at Port Kembla is equipped with the facilities which have been used to test concentrate from the Lady Annie and rock from the Duchess deposit for phosphoric acid and fertiliser production. The material has been analysed for content, and the proportion of deleterious impurities are well within trade requirements. Test work at these laboratories and overseas has shown both the Lady Annie and Duchess product to be suitable for phosphoric acid manufacture. A full-scale plant trial at the Wallaroo works at the Adelaide and Wallaroo Fertiliser Company has confirmed the Duchess phosphate as a suitable raw material for superphosphate manufacture. Although the bore water supply is adequate for the pilot plant, a large permanent supply will be required for later development and will involve the construction of a dam on Gunpowder Creek, some 20 kilometres further east. Transport cost is critical to the success of this venture. A slurry pipeline to the Gulf of Carpentaria provides an economic solution and would be the first time the technique has been employed on the Australian continent on the scale envisaged. The proposed slurry pipeline will be 314 kilometres in length and will take the product to a deep water port in the Gulf. This route will traverse a widely varying terrain from rugged highlands onto the extensive black soil plains until it reaches the coast. The Gulf is a sunken coastline with extensive tidal flats, river estuaries lined with mangrove swamps, and shallow water extending far out into the Gulf. Burketown, the nearest mainland town, is located on the Albert River, which is only navigable by shallow draft vessels. Here, the pipeline will dip into the sea for the last 30 kilometres and emerge at the southern end of Swears Island. The concentrate will be dewatered and dried for loading into large bulk carriers berthed off Inscription Point. This sheltered harbour was originally discovered by Matthew Flinders. The dewatering plant and township will be built nearby. From this strategic centre, shipment will be within convenient range of phosphate receiving ports in Australia and neighbouring countries. Slurry pipeline transport to this port site will solve the transport problem from one of the most isolated areas of Australia. Before the Swears Island Lady Annie development is initiated, the Duchess deposit will be brought into production. This deposit lies only some 50 kilometres from the existing Mount Isa-Townsville railway. But until the increase in the world price for phosphate in late 1973, it was uneconomic to use rail transport. Previously, extensive drilling had shown the existence of substantial reserves of direct shipping grade rock in the Duchess deposit. Exposure of these phosphate beds was made in a number of excavations near Phosphate Hill to confirm continuity and to provide samples for testing. The decision has been taken to construct a spur line south to the Duchess deposit where phosphate rock will be loaded into unit trains and railed to Townsville for shipment. The Queensland Railways have extensive experience in building and operating lines from isolated places inland to the coast. It has done this for the copper, lead and zinc deposits at Mount Isa, and more recently for the coal deposits in the Bowen Basin and nickel ores from Greenvale. This is the type of operation which will be needed for the Duchess phosphate deposits. In this case, the city of Townsville, 1,100 kilometres north of Brisbane, will be the rail terminal. This centre is a major port through which the mineral and agricultural products of the hinterland are shipped to world markets. Large areas of reclaimed land are available for the company's facilities, and phosphate will be shipped to the consumers in Australia and overseas. BH South Limited is one of the oldest miners in Australia and traces its origins to the 19th century in Broken Hill, where it operated the South Mine on the world's richest silver lead zinc lode. Over the decades, the company has grown and diversified, so that today its interests are widely spread in the mining and fabricating industries. In addition to developing the phosphate deposits through its wholly owned subsidiary, Queensland Phosphate Limited, the company has developed the Cobar copper field with new mechanized methods of underground mining, giving renewed prosperity to this outback region. At Kanmantu in South Australia, it manages an open-cut copper mine, a recent addition to the Australian mining scene. BH South has a majority interest in this operation. The open pit, which is 500 metres across, will eventually reach a depth of 230 metres. The autogenous mill, one of the few of its type operating in Australia, has a design capacity of 100 tonnes per hour. This operation does not require the addition of steel in the grinding process. At Port Kembla, the BH South subsidiary, the Electrolytic Refining and Smelting Company, operates a custom copper smelter and refinery. The techniques employed enable the company to market copper of a quality comparable with the leading refineries overseas. Alcoa has developed as the largest integrated producer of aluminium in Australia, with plants at Point Henry in Victoria and Kwinana and Bunbury in Western Australia. BH South is a foundation shareholder in this enterprise. Mines Exploration Proprietary Limited, headquartered in Adelaide, is the company's exploration subsidiary and was responsible for the discoveries of phosphate rock. The BH South group of companies has been in the forefront of Australia's growing mineral development and has contributed to the nation's prosperity. The successes of the past give only an inkling of the wealth waiting to be found, perhaps in some underground forest, or vanished sea, or great stony desert within the vastness of this continent.